Hello everyone. So today we will complete the second part of your chapter, that is the electroscope. Okay. Now electroscope is an instrument which is used to test whether an object is charged or not. Okay. Their operation is based on the principle of like sign charge repulsion. Okay. If there are like charges, obviously it will repel. So on that principle, a Goldleaf electroscope works. When the leaves of the electroscope, they are electrically connected with any object, they become electrically charged and they push apart from each other. That is, the leaves of the electroscope diverge. Now in your book, the construction of Goldleaf electroscope is given. Okay. So you read the construction part of Goldleaf electroscope. Okay. Now we will proceed to the experiments with the Goldleaf electroscope. How we will charge a Goldleaf electroscope by conduction. Conduction means what? An object, with the help of an object which is already charged, when we will place it near the Goldleaf electroscope will also be a charged body. Okay. So what we have taken? We have taken, say suppose an ebonite rod. Okay. Say suppose I'm showing you one example. Say suppose this is an ebonite rod. Okay, this is an ebonite rod and I have placed the ebonite rod, or I have touched the ebonite rod at the brass disc of the electroscope. Okay. When this charged object came in contact with the brass disc of the electroscope, the leaves of the electroscope which are present at the bottom of the brass disc, they will diverge. Diverge means what? They will push apart from each other. Why they have pushed apart from each other? Because I have touched the charged body to the brass disc. Okay. Now I will repeat the entire process. I will place the ebonite rod again and again until the divergence increases. At last, when the divergence will be increased at some point of time, then we will say that the electroscope is electrically charged. Okay. The next experiment is to detect and measure the charge on an object. How we will detect and measure the charge present in an object? First of all, say suppose an object which is to be tested is placed to the brass disc. Now this is an uncharged electroscope. It is not charged. Okay. So suppose in the uncharged electroscope, I will place an object which is having a charge to the brass disc. Okay. Now, if the object is charged, if any object, say a glass rod or an ebonite rod or any other object, if it is charged, then what will happen? The leaves of the electroscope, they will move apart from each other. They will diverge. Okay. As you can see in the picture, the divergence of the leaves, you see, this is the divergence of the leaves. Okay. Now, the amount of divergence, more amount of divergence means more amount of charges are present on that object. Okay, this is how we will detect and measure the charge which is present on an object. Okay, now how I will identify that what kind of charges are present on an object? First of all, say suppose this is a Goldleaf electroscope, isn't it? Now this Goldleaf electroscope, on this Goldleaf electroscope I will place a charged object. Okay, charged object to make it either positively charged or negatively charged. Okay. So, first of all, we will touch the brass disc of the electroscope with either a positively charged or negatively charged object. Okay. Now, the leaves will acquire the same charge. As soon as I will place the charged object near the brass disc, the leaves will diverge. Let us assume that the electroscope is negatively charged. Okay. Now, we will bring the object which is to be tested to the brass disc of the electroscope. Okay. If the object is negatively charged, then the electroscope is also negatively charged, and as a result the divergence of the leaves will increase. Means what? Repulsion. Electroscope is also negatively charged, object is also negatively charged, means what? Negative repulsion will happen, and as a result the leaves will diverge. But if the object is positively charged and electroscope is negatively charged, then what will happen? Divergence will be less, means the object is having opposite charges. Opposite charges attracts. But in Goldleaf electroscope, their main principle is the principle of repulsion. Attraction doesn't work here. Main is repulsion. So what will happen when the object is negatively charged and Goldleaf is say positively charged? When I will place the object to the brass disc, then what will happen? Divergence will decrease. Okay, this is how we can assume that electroscope can be a negative, can have a negative charge, or the object can have a positive charge, or the object can have a positive charge, or Goldleaf electroscope has a negative charge. Okay, next topic that you have is conductors and insulators. Conductors are actually those substances that allow electric charges to flow through them. They are called as conductors. And insulators are those substances which do not allow electric charges to flow through them. They are called as insulators. Okay, now if a charged object they loses their charge, then what will happen? We will say that the charged object which has lost his charge or its charge, they are said to be discharged. And the process of transfer of charge from a charged object to the earth, they are called as earthing. Okay, so in the next video I will be uploading the next part of your chapter, that is atmospheric electricity and earthquake. Okay.